to video 4, technically, covering Chapter 3. And this is the last video for week 9. The rest of the videos are going to be up for week 10. And I should get those up within the next couple of days. So today, what we're going to cover, this video does cover a lot. So just so you know, you might want to pause it and take a break in between at some point. Yeah, so today we're going to cover logical operators, and we're going to go pretty deep into that. And then we will do some if-else statements, which are very similar to things we've seen in Excel. Then we will work on using the logic we learn at the first part. We're going to learn to use that in functions, which we covered briefly in the previous video. And then lastly, we're going to cover while loops, which I will get to what that is later in the video. Okay, so starting with logical operators, and again, you can follow along. This is Chapter 3 in the How to Learn R guide that is up on Canvas. Okay, so there are two types of logical values, and that is true and false. And so in R, we can ask R something that will return a value of true or false. And we can also assign these values to variables and do some other stuff with them. So we're going to kind of just walk through that. Okay, so here what we're going to do is assign a variable x and y to different variables exactly the same way we saw in a previous video. So here we're doing x gets factorial of 5. We can just press enter on that. Y is going to get the exponent of 5, so we can just press enter on that. And then what we're going to do is basically ask the question to R, is y greater than x? And we're going to use the actual variable names to do this. So when we press enter, you can see that it returns the value of true. So true is a logical data type. It could have either returned true or false. Those are the only values. Okay, so that's kind of how you can ask R these kinds of questions to see if they're true or false. But we can also assign that same type of logical expression to a variable itself. So here we have C gets 3 times 12 if it's greater than or equal to 4 times 8. So remember, if we were just to type out this without assigning it to a variable, we would get a true or false whether or not 3 times 12 is greater than or equal to 4 times 8. But here we're just going to assign it to a variable first, and we can see it doesn't give us a result of true or false yet down in our console. But if we type out what C is, we can see that it returns the value of true. So here, when you're using a logical operator to actually assign a variable, when I type in C to see what it is, I'm not going to get the value back of, I'm not going to get 3 times 12 greater than or equal to 4 times 8 written out. That information is gone. I'm only going to get the value of true or false because I passed a logical expression. So we can also use some other logical operators that are going to get us values of true or false. And in the chapter, there are actually a couple tables that go over these, and I would really suggest looking at them to familiarize yourself with what they are. This way you don't have to look them up every time you want to know how to write them out. So to go through these, and again, I'm going through the examples. So this is example 3.2.1 in the guide. So to start, what we're going to do is just like we did up here for C, we're going to assign A the value of whether or not whether or not 3 is less than or equal to 8. So we're just going to do that. Then B gets is 20 greater than 20. And we can see, right, like 3, is it less than or equal to 8? The answer is true. Is 20 greater than 20? The answer is false. So we can also think of A, down here you can see, is true, and B is false. So now what we're doing using A and B is essentially the same thing as using the value of true and the value of false to check other logical statements. So this one, using the ampersand or the and symbol, is asking, is both A and B true? We know, because A is true and B is false, that the answer should be false. So if we type out that code, press Control Enter on that, we can see A and B is false because A is true, but B is false, meaning A and B are not both true. So the result is false. Next, we have not B. That is your exclamation mark. That symbol means not in R. So if you type this out, exclamation mark B, what it's going to read as is not B, or basically the opposite of B. So not false equals true. And we can see that knowing that B equals false, typing out not B, if we press enter on that, we get true. So that's important to remember. Basically, you can negate your trues and falses using that symbol. Okay. So here we have this this example that kind of just goes through a bunch of like kind of longer logical strings, and I'm gonna walk through them kind of briefly. If you don't understand this part, I would suggest taking time to walk through it and understand the logic of it, because it is pretty important for kind of getting and understanding logic in coding kind of generally. So here we're using, again, the and symbol means and, that straight line up and down, that means or. So we have and or. So what this is saying is A and B, remember what we saw in the previous one, so is A and B true, or is A true? So only one of them has to be true. Knowing that A is true, we should expect this to return the value of true. If we press enter, we can see that it does. So moving on to the next one, we have not B, which we know is true, right? Because it's not false. So not B, or A and A, or A. So only one of these has to be true for the entire string to be true. And we know our first one is true, we know our second one is true, and we know our last one is true. So this should definitely result in true. And it does. Okay. So the next one is A and B, which we know is false, or B and A, which actually is also false. So this should get us a false. And it does. Okay. Now we have a not sign in front of another statement. So we have not B, or not A and not B. So this is false. To walk through why, which I suppose we should do, if we have not B, we know that that's true. Then we have or, which we have not A, which is false, and not B, which is true. So this entire statement is actually false because not A is false. So we have true or false, which actually the entire thing of that is true, but we can't forget this not symbol at the front here that gets applied to this entire thing. So this might be true, but then we have this not symbol in front of here, and what that means is not true, which is why we get false for that entire long string. Okay, so last example here, we have A or B, and we're putting these in parentheses to kind of separate these statements, right? So we have A or B is its own statement, and we know that since A is true, this entire thing in this parentheses here is true because it's or B. Then we have and not A and B. We know that A and B is false because B is false. But we have this not symbol in front of that parenthesis. So we know that this is false. This is going to negate that, which means this is going to be true. So we're going to have a true statement because it's A or B, and a not false statement or a true statement. So these should both be true, which should result in the entire thing being true. Okay, so again, logic and logical operators like this, they take some time to get used to, but I really just recommend walking through these examples, walking through the practice problems, and reading them reading them as trues and falses, and reading them from left to right, the way that you kind of would read a sentence, and kind of trying to figure out the logic within each one, so you really have a good grasp of it. Okay, so that does it for 3.2, that section on logical operators. So section 3.3 is if-else ladders. So we're going to get into if-else statements, which we covered in Excel, so hopefully it should be a little familiar. Really just the syntax is going to be a little bit different. So we're going to walk through how these work. Okay, so for starters, we are assigning a variable. We're calling it S, and we're assigning it the value of 85. It's arbitrarily chosen, but that's just what we're doing. So S takes the value of 85. Next, we're going to use an if statement. And it's important to know how if statements are structured in R. So the way you do it is you do if you have a condition inside of your parentheses, and then you have curly brackets, the same ones we saw when we were creating functions. This is doing a very similar thing. So inside the curly brackets is what is going to get returned or done if our logical statement inside is met. If our condition inside the parentheses is met, then it will execute the thing inside the curly brackets. Okay. However, actually we can do here. So just to see what this does, let's assign S, and let's run just this if statement. Okay, so it ran it and nothing happened. So why is that? If we look at this, and I just ran this first part, we have if S is less than 60, basically print the letter F is what it's telling it to do. And so if we look at what S is, it's 85, which it's not less than 60, which means our condition hasn't been met, which is why our running that code didn't actually result in anything. So the point in adding an else statement, or multiple else statements, is to cover the range of possibilities. So if we want to read through this if-else ladder, we can do it really kind of like reading through a sentence. So I'm just going to read through it. If S is less than 60, print the letter F. If it's not, else, we're going to check it again. So if S is less than 70, print out the letter D. If not, else, we're going to ask again. If S is less than 80, print out the letter C. If it's not, else, we're going to ask again. If S is less than 90, print out the letter B. If that is not met, if that condition isn't met, else, print out the letter A. And so what we're doing by ending on an else statement is we're exhausting all our other possibilities. So if we end on an if statement, we might not have exhausted the possible options, the possible logical options. However, if we end on an else statement, it means anything that wasn't covered in the previous if statements, just assign it this last value. It's going to just do this last thing. So it's kind of important to get the logic of that. So if we run this entire thing, and our else and if statements actually tell R to keep running it until it gets to the end. So if we run this whole thing, you can see that it ran the entire chunk of code without me having to highlight all of it because it's actually all connected as one. And you can see that it printed out B in quotations. So if we look at our loop, B gets printed if S is less than 90. And we can see that S is 85. We can check our other conditions, right? So S isn't less than 60, S isn't less than 70, S isn't less than 80, S is less than 90, so it prints B, and that's kind of how that works. So you really read through it the same kind of way as you read through these logical operators. You just read through it logically as if it were a statement, which can really help with kind of understanding how it's working and what it's doing. Okay, so that was example 3.3.1, letter grades. So this had to do with the example is built off of assigning letter grades based on a score. But maybe you want to actually store that variable. You don't want the variable to just kind of disappear. You don't want the letter grade to disappear. You want to actually store it somewhere so you could go check on this grade afterwards. So in example 3.3.2, we're actually doing a very similar statement, but we're just assigning it to a variable name. This way we can access it the same way we've been accessing our other variables in the future. So again, S is 85. And here we're doing a similar if statement, but first we're writing G gets that if statement. You can see almost everything else is the same in our loop or very similar. However, we've specified whether or not it's equal to a value. So here, G is going to get the letter A if S is greater than or equal to 90. Otherwise, it's going to get the letter B if it's greater than or equal to 80. Or it's going to get, it's going to get the letter C if it's greater than or equal to 70. Otherwise, it will get the letter D if it's greater than or equal to 60. And any other values that this number is going to take is going to get the value of F. And so it's also important to I just want to point out, it's important to know the logic of this and to know the data that you're working with. So if we were actually applying this to a whole set of grades to assign them, we'd want to make sure that we don't have anything that could fall into the wrong category. So we really want to make sure that our loop is exhaustive. And we can see that it is, sorry, not your loop, our if statement, if it's exhaustive. We can see that the first statement is just greater than or 90. That covers all values greater than 90. And our ending with our else statements covers any other value not in the loop that was previously mentioned. So we can know that it covers every number greater than 90 and every number less than 60, which means we're covering our all possible numbers, well, real numbers, but we don't need to get into that. So it's important to read through your if statements and make sure they kind of cover everything you're interested in. Okay, so we're going to now just assign this to G. You can see it doesn't print out a result like our previous one did. We have to actually type out G on our own to get what the value is, because that's how assignment works. So we can see that based on what S is, what we've previously specified, G is B. So the grade we would assign to that score would be a B. Okay, so next we are going to talk about different classes of variables or of values, really. And these are important to keep in mind. When it comes to other coding, this is actually very important. But for our purposes, we're just kind of going to touch on it so you can know the differences between different classes of variables. So there are different types. If you actually look in our environment window over here, you can see that our various variables, and these are from some of the other videos, actually have a type. And that is what we're interested in here. So we have numeric, logic, character, function, different types. So if we want to know the class of the number 123, we can type class on it, and it will tell us that the class of that number is numeric. So what we've been working with today are logical operators. So we have 12 greater than 3. The class of, we know that that is true, but the class of it is logical, right? It's one of our logical operators. So if you ask for class on something that is either true or false, you're going to get back logical. Then we have class of 12.3. That is also numeric. So here we have 123, including decimal places, it's still a numeric value. And finally, we have class of, in quotations, 123. That is a character string. And we know that because it's denoted by our quotations. Anything within quotations is a character. And you can always tell whether it's a character or not because it turns this kind of bright green color, at least within RStudio it does. So we can check our variables as well. We don't have to do this to just numbers. So our previous variables, we have S and G. We can check the classes of each. We know that S, because it was 85, is a numeric variable. G is a character because remember G got that value over here of B, and it is in quotations, so the class of G is a character. Okay, so moving on, we can use our, we can actually make logical functions. So we can make functions that return the value of either true or false, depending on the input we give it. So we're gonna go through a couple of those. This first one, we've named it is greater than 10. So no surprise, this function is basically asking if a value is greater than 10. So we name our function, we assign it our function operator here, so function, and then we're only passing it a single value, so we just put val. Remember in previous functions, we've seen individual characters, so like A or B. You can actually have it be an entire name. And so it's not going to read these as separate input variables unless they were separated by commas. And we saw that in the previous video with our multivariate function. So here you can actually just type out val, and then as long as you use the same string of letters in your actual function, it will read it the same. So this function is taking a value named val, and what the function does is it returns whether true or false if that value is greater than 10. So remember with functions, we can assign it by pressing enter on that. And now locally in this session, we have that function saved, and we can now just use it as we would any other function. So here we'll go through some examples. We have is greater than 10, 19. So this is asking, is the value 19 greater than 10? If we press enter, we can see that's true. For is greater than 10, 9, we should expect false, right? We get that. And is greater than 10, 10, we get false because 10 is not greater than 10. Okay, so that's a simple example of how to use a logical operator. But we can also do this. We can combine all three of what we've been doing, logical operators, functions, and our if-else ladders into one thing. They all work together. So in this function, what we're doing is we're using an if-else ladder to determine if the value we have is negative, positive, or neither. So we write out the name of our function, positive or negative, abbreviated a little. Then we assign it our function. It's only going to get one value, so we just put val, and then our curly brackets. And then this entire thing is going to go in these curly brackets. So if you see, when I go next to this curly bracket, it highlights this in gray all the way down here, which means the bracket that closes this curly bracket is all the way down here. And that you want to be able to check that because you want to ensure that everything else you're doing is inside your function. Okay, so here we have a function that takes a value, and what that function does is that it asks if this value that you pass it is greater than 0, you're going to type out positive, or it's going to return the string, the character string, positive. Else, so if it's not greater than 0, it's going to ask again if the value is less than 0, it's going to print out the character string negative, or return the character string negative. If neither of the previous if statements or conditions are met, then it's going to do another else, and anything that doesn't meet those prior two conditions of being greater than or less than 0 is going to return the character string neither. And so if we press enter up here, it will run that entire function, and now we have it locally saved and we can run it on different numbers. So this function is now going to ask, is the number 1,333 positive, negative, or neither? We're going to get, when we press enter, we're going to get the return value of positive. So we can see that that number is positive because it's greater than 0. Here we have negative 26. We should expect that to be negative. If we run it, we see that it is. And last but not least, if you're wondering what would be neither, well, it's the value of 0. If we run our function on the value 0, we get neither. So we can see that our function works. Okay, so moving on to one more example that combines these things, just because it's pretty useful to kind of work through more than one. It can be kind of a lot to get used to using these. Okay, so this is going to be example 3.4.3. You're making a sum and product function that basically wants to see whether or not the sum is greater than the product, or vice versa, or if they're equal. So we're just going to read through this function that we've written here. We have sum or product, the name of our function, gets the function operator, or the function command, which takes the variables a and b. We know that these are separate variables because they're separated by a comma. So this function takes two variables, or two values, both a and b. Okay. So what does this function do? Inside our curly brackets, we can see that it runs an if statement. So if a plus b is greater than a times b, we are going to return this character string sum is greater than product. If that condition is not met, else, we're going to run another if statement. If a plus b is less than a times b, we're going to return the character string product is greater than sum. However, if neither of those two conditions are met, else, we're going to return the last option, which is product and sum are equal. And we can see that we've exhausted all of our logical options, right? We have, it could either be greater than, it could be less than, or it could be neither, right? In which case they're equal to each other. That's the only other option. And so we've exhausted every single option. So we know that whatever values we put into our function is going to return an actual value, which is good. It's something you want to ensure when writing functions like this. So if we run this, it ran properly, didn't throw any errors to us. That's good. We can then use this new function that we've created and run it on our variables. Now, I just want to remind everyone, if we try to run a function on a single value that actually needs to take two values, it is going to throw an error. It's always important to remember that if we get an error, to read it, to look at what it's telling us, and see if we can figure out from that what we did wrong. So here we have error in sum or product 3. Argument b is missing with no default. I did not supply this function the argument b, and it requires it requires an argument of b to actually run. So if we go back up, If we go back up and put back our 4, separated by commas, we have a and b. We can run these. So product is greater than sum. So here we know that the product of our two values is greater than the sum of our two values. If we run it on -1 and 3, we can see the sum is greater than the product. So adding them together is actually greater than multiplying them together. That's because 2 is greater than -3. And here we can do sum or product 2 and 2. We know that 2 times 2 is 4. 2 plus 2 is 4, so they should be equal. And it returns the value product and sum are equal, so our function worked. Okay, so last but not least, we are going to talk about while loops. All right, so as you can see in the manual or guide, while loops can do lots of stuff, but we're only going to talk about 2 of those applications. There are a lot more, like running loops in R is something that once you get used to doing it, you would do a lot. In fact, in terms of coding and stuff, running loops is, one of the main things you're going to be doing, along with things like functions. But we're just going to touch on them. So there are 2 types of loops in R, while loops and for loops. We're going to talk about for loops in chapter 4. That's the next video. But we're just going to talk about while loops here. So the 2 applications that we're going to be talking about in this video and in this module really are increment, transformation, and value attainment. And we're going to go through each one of those. So, right, to walk through what each thing is, we've set this variable named counter. We don't have to name it that, but we're trying to be informative. So our counter is going to get the value 1, meaning it's going to start at the value 1. Then we've written out result, that's another variable, and we're setting it to 0. So these are starting variables. Before we run loops, oftentimes you set your variables at a certain number to start with. Next, we're going to run a while loop. And what while loops do is you set a condition for the while loop to run. And so what it does is it checks the condition. If the condition is met, it runs the loop. And then after it's ran the loop completely, it goes back. It asks if the condition is still met. If the condition is met, it runs it again, and it'll keep doing that over and over until it goes back and checks and sees if the condition is false. If that while loop finds that the condition is false, it will halt the loop and it will stop running. So it is important to remember with while loops, like if you don't supply it a condition that can actually be falsified, you're going to be in trouble because you're going to run this loop that's going to just keep running potentially. Like if you don't throw an error and you get this while loop to run, but your actual condition can't return a false, then you're going to be in trouble because this while loop is just going to keep running until you realize, oh, oops, I messed up. So be aware of that when running while loops. For loops don't have this same issue, but we'll get to that later. So, okay. Basically, you want your while loop to increment through your values. This way it can keep checking that condition and it will actually change. So here we have while counter is less than or equal to 1,000. So remember, we set counter up here. We could have named it whatever we want, but we're saying that the condition we're checking for in order to run this loop is that counter, the value of counter, has to be less than or equal to 1,000. If that condition is met, which we can see that to start with, 1 is less than that value, so it is going to run. What it's going to do is it's going to take our result variable, and then it's going to manipulate that variable by adding the counter value to it. So it's going to start with 0. We're going to then get result, or 0, instead gets reassigned a new value of result plus counter, so 0 plus 1. So it's going to then take 0 is going to become 1, and then next, and you read these as separate lines, but they're all within the same while loop. Next, what it's going to do is it's going to take counter and it's going to increment it by 1. You can see that this last step is really important because if we don't increment our counter, it's never going to change. It's always going to be less than or equal to 1,000, and we don't want that. So we want it to be able to stop, which means that we have to actually add this plus 1 here in order to get it to halt our while loop. So I'm just going to run through these and show what happens. So we have counter, result, and let's run our while loop. It runs very quickly because it's a very simple loop. If it weren't, you would get a little stop sign here to show you that R is kind of working on something, and you'd have to wait until it was done to run the rest of your code. Okay, so we want to know what our result is, and our final result is 500,500, I think. Yeah, so we can see what it did to get that number. It took the result and added 1 each time it incremented. And it incremented by 1, as you can see with the counter. Okay, so that's a basic while loop that is creating a summation. So next we're going to run through a different while loop example. It's still going to use a counter variable and a result variable. It's still going to use that same condition actually, but it's going to perform a different thing. So instead of adding, what it's going to do is ask, is the counter less than or equal to 1,000? If it is, result is going to get result plus the square root of counter. So we're going to actually increment by a smaller number now. And then after it does that, the counter is going to increment by 2. So it's actually going to stop this loop faster because we're incrementing it faster than in the previous one where we only added 1 each time. So here we can run this one more time. And we can see that the result is 10,556.45. Okay, so while loops, while they can get much, much more complicated than this, it's helpful to start with these simple examples to be able to read through them and make sure you understand what it's doing, how it's updating itself, and how it's determining whether or not it should run or how it determines when to stop. If you understand those basic parts, I think you'll have a good enough grasp of while loops to kind of, well, for one, do well on the test, but also if you want to go further with coding to be able to kind of build on it. Okay. So moving on to example 3.5.3, we have compounded interest. So again, really simple, similar while loop, but we're doing a different thing. So we have counter, our result. Our result, you can see, is starting at a larger number. And this time, instead of looking at the counter, we're looking at the result. So now we want to stop after our result hits a certain thing. So here we're kind of doing the opposite, where we want to see how long it takes us to get to a certain result, rather than up here, we are wondering after a certain amount of time what our result was. So here, we're setting our counter to 0, setting our result to 100, and this loop is going through and saying, while the result is less than 200, run the loop, result takes result times 1.03, and then counter is going to increment by 1. So we can run this, and then instead of looking at the result, because the result's not that interesting, right? We know that the result is going to halt after it is greater than or equal to 200, because that's what we set it at. So if we look at result, we can see, okay, it stopped once it got to 203.2794. But if we look at counter, we can see that it took 24 steps to actually get to that value. So this is different information that we're interested in. We can do the same here, where we have counter set to 0, result set to 0, and we have a while loop, which let me run those. We have a while loop that says, while the result is less than or equal to 100, run the following loop. Result gets result plus 10 times 1.1 to the value of counter. Counter is then going to increment again just by 1 each time. So we can run this, and we can see with this expression how many iterations of this loop does it take to get over the value of 100. So if we run counter, we can see it only took 8 iterations. So it actually got to that pretty fast. Okay, so I know this video is very long. This is it for chapter 3. Please try to go through the practice problems. Again, the answer key is in the manual. So please try to practice. I wanted to mention, I am going to upload these scripts. You can see chapter 2 and chapter 3. I'm going to upload these scripts to Canvas as well, so that if you want, you can download the scripts and actually walk through these examples without having to write them up yourself, just to be able to play around with different stuff. I would encourage you to also be able to write your own scripts following along. Because you are going to be asked to write all your own original code in the quiz. So if you don't feel comfortable doing that, please practice. But yeah, I just wanted to let you know that they will be on Canvas. Okay, that's it for chapter 3. Thank you for sitting through such a long video. And we will get to chapter 4 next time.